Hello, everyone. This video will be going over our Unit 3 test review. We have a Unit 3 test coming up this week, and I want to give you guys examples about what kind of questions you could expect to see on your test. So, scrolling down, first type of question you're going to have on your test is how to prove equivalence. So, we talked about equivalence very early in this section. It was the first unit we went over. And in order for things to be equal, they need to be represented or simplified and be the exact same way on both sides. So you're going to try and manipulate both sides by either factoring, simplifying, or expanding in order to try and make these uh, expressions equivalent to one another. So looking at my question, it's telling me to compare these two expressions and tell whether or not they are equal. So let's see. I could either try and factor this side, or I could try and multiply out and simplify this side. I will show you both methods just to prove that one could absolutely turn to the other. You can start with both sides in this case. So let's see. I'm going to go ahead and multiply out my two expressions. Not make it so slanted. Let me adjust my. There we go. Okay. And we're going to have, since we start with our parentheses always populate the outside of our box. So that's going to be x and negative 2, x and 7. That's going to give me x squared minus 2x, 7x, and negative 14, which will give me x squared minus 2x plus 7x minus 14. And when I simplify, this, of course, does equal to, I'll just set it equal right here. That's going to be x squared, negative 2x and 7x do give me positive 5x minus 14. So already at this point, I can stop and show that, hey, I was able to simplify this side so that it exactly matches the other side. So I could say, yes, they are equivalent. And of course, my showing my work, this is me justifying and proving my answer. So you can't just say yes, you must show me how you got there, how you're able to simplify and get them to be the same way. As I said, I could also start with the right-hand side. So if I wanted to do that, so let me start from here this time. I'm going to make my box, and this time I'm going to start with my x squared and negative 14. When I have my standard form, I start with populating the inside of my box first. And of course, I try and look at negative 14 and I try and figure out, okay, what gives me 14? And the only combinations I can think of are 2 and 7, 1 and 14. If I use 2 and 7, I'm beginning to match what I have over here. And I have a negative to distribute, so if I throw a negative on a 2, now I exactly have what I need. So that's going to be negative 2x, 7x, and what's get populated is x minus 2, x and 7, which will give me x minus 2 times x plus 7, which exactly matches what I began with on the other side. So whether you start with the left side or the right side, if you simplify the left side or factor the right side, you could get the forms to be equivalent to one another, which is what we're looking for in this type of question. Now, going on to our next example, it says, uh, ignore the mini whiteboard stuff. We were hopefully going to do this fast, but we did not have the time for it. So we're going to rewrite the two expressions the exact same way in order to prove equivalence. They must be written the exact same way. So here, both these sides just need simplification. So I just take my outside values and distribute into my variable or inside my parentheses. So that's going to be 2x times 2x, which will give me 4x squared minus 6x, which I'm seeing components starting to match. So let's see, negative x times negative 4x will give me 4x squared. Negative x times 6 will be negative 6x. And in this case, I did need to simplify both sides. If I just simplify the left side, it still doesn't match my right side. So I needed to There we go. I needed to simplify both sides, manipulate both sides in order to get them to be exactly equal. So once again, the answer is an emphatic yes, they are equivalent. And in our final equivalency example, this is going to be, once again, I'm going to simplify, and I'm going to simplify both sides. Let's start with my left side. We'll do that in red. Well, actually, we'll start this one in black. We'll do the left side and right side in red. So I need to simplify both sides. Let's see if these match exactly when I simplify. So x, I'm going to, ooh, I was about to distribute first, and then I saw this guy right here. Remember in PEMDAS, we always do the parentheses, exponents, then multiplication, division, and addition, subtraction in that order. So if I have an exponent, I must resolve that exponent first before I do anything else, which means I'm going to rewrite this as x plus 4 times x plus 4. Now, I still like to deal with my parentheses first. So I'm going to multiply those out. I'm going to get x squared plus 4x plus 4x plus 16, which will then get me x to the third plus, well, I should simplify this first, or at least show you. That 4x plus 4x gives me 8x. But multiplying that x in gives me the value x to the third plus 8x squared plus 16x. And that's the fully simplified version of this left-hand side. Looking at this right-hand side, here I have no power, so I could just multiply everything straight in. So this is going to be x squared plus 8x squared minus 16x. Now already there's a problem because here I have an x to the third, and I have no x to the third values here. But let's fully simplify and double check me did everything correctly. X squared plus 8x squared will be 9x squared minus 16x. And I'm fully simplified, and these two do not match, which means that they're unequal, which means the answer is no, they are not equivalent. No, not equivalent. And I show that by saying, hey, I simplified both of them and I wasn't able to have them match each other. So in order to disprove equivalence, you need to prove that the forms are unequal. I both have these in my simplified form, and when they can't reduce any further, we can see that, yeah, they are unequal. They don't have the same power. We reduced them, we simplified, and they were not equal. So that's how we could prove that they're unequal because we got them in the same form and they do not match. Another way that it's good to know if you want to use this method, you absolutely can. We went over it briefly, but you could find a counter example. Also, if you plugged in an x value into here and plug that same x value into here, you would get different results. So if that's your method of choice, you're more than welcome to. But for this review video, we're going to go ahead and explore and make sure that we uh, stay on topic of changing the forms to prove that they are unequal. Okay, so we're talking about equivalency. Now we need to actually test, kind of like we did in this example. We need to test, hey, is it equal or is it not equal? This is kind of the question that you're going to get on the test more often than not. It's not going to tell you, hey, this is equal, prove it, this is unequal, prove it. You need to, through your own research and through your own work, decide these are equal to one another or these are not equal to one another. So let's go ahead and see. This example, hopefully we're very familiar with, is does this squared give me this value over here? And automatically our antenna, our radar should be up because we know that we're not just going to square and square here. What needs to happen is when I have a parentheses squared, I need to write that out twice. That's going to be x plus 5 times x plus 5. And from there, I can multiply them out to give me x squared plus 10x plus 25 is equal to x squared minus 25. Now, is this statement true? Well, no, because they're both in their most simplified form. This one has a 10x, where this one does not. Also, our 25s are negative and positive, so they do not match. So, getting them in the same form, we could succinctly say that these two are not equal. Or, in other words, the statement is false. Because the statement is, or the equation rather, saying, hey, these two sides are equal, and we're saying no, no, they are not. Okay? And I will leave you to do this question on your own, make it make sense, see if you could play around with it, see if you have trouble or not. Mm, so please work on this one. If you have questions, please feel free to email me or come ready with your questions at the beginning of class, as we will have a review time before we get into the test. All right, scrolling down to our next topic. This seems to be a repeat. Yeah, I just put the same question twice for some reason, so you could ignore that. But the next thing that we're going to do, the next thing we're going to go over, and the next type of question that's going to be on your test is now we need to meaningfully rewrite an expression. We need to meaningfully rewrite an expression. So we've talked about what that means in class. And the basic idea is that we need to change the form. If you just separate two numbers, like if I give you 5, you're saying, oh, that's the same thing as says 2.3, 2 plus 3. That's not going to cut it. We need to change the form. We're not just separating numbers. I know you guys know addition and subtraction, but this being an Algebra 2 class, I'm holding you to an Algebra 2 standard. You must change the form. And those three methods of changing the form are in simplification, and factoring, and expanding, all of which that we have covered. So looking at our first example, this, I tell you straight up, this is a simplifying example. So I have my expression 2x minus 3 squared minus 54. And you'll notice that I have a lot of stuff going on here. I have a power to a parentheses. I have multiplication here. I have subtraction with some numbers. This can be simplified. And what we mean by simplification is using our PEMDAS rules. Just solving as much as we can until there's no more to solve and we have our final simplified version. So let's go ahead and explore what that's going to look like. First things first, I'm going to expand out my parentheses to the power of 2. So I'm going to just write it out twice. And I'll tell you right now, this already is an equivalent form. So I'm going to go ahead and label this EF1 to signify like, hey, I expanded out the power. So rather than writing the power, I wrote up parentheses twice. That is one way of changing the form. And this is an equivalent expression. These two are equal to one another. I derived this expression from this expression. They look different, but the values are the same. They are equivalent. So the best way to find equivalent expressions is also just simplifying and just trying to recognize when you change the form, and just catalog your answers that way. You don't need to finish simplifying. In this case, I'm looking for 3 equivalent expressions. So as soon as I find 3, I'm going to call it a day. I do not even need to keep going. That being said, I also know that I could multiply these parentheses out. So this is going to be 2x squared minus 6x plus 9 minus 54. And this is going to be my second form. I multiplied out my parentheses and I got some new results that is not looking the same, but they are the same form. So I'm going to say this is my equivalent form number 2. From there, I'm going to multiply this in, and that's going to give me, if I distribute my 2, that's going to be 2x squared minus 12x plus 18 minus 54. And this, ladies and gentlemen, is also a new form. So this is my equivalent form 3, and I am done. So I'm not fully done simplifying, but I found my 3 equivalent forms, so I'm gonna call it there. One last thing. If you do get to this form and you continue to simplify, I just want to note, what is 18 minus 54? Calculator. So that's going to be 54 minus 18, 818. And that's going to give me 36. Which for bigger things, that's going to be minus 36. So if I go from this form to this form, I would not count that as a new equivalent form. These are equivalent, but like I said, I'm not going to count just the separation of numbers. I know that 18 minus 54 is 36. That's not enough to be considered a new form. However, if you want to factor this to get even more forms, you absolutely could. But like I said, as soon as you get your 3 new forms, call it there. Don't make life harder for yourselves. Just make sure that you identify what those different forms are so that I know that you know what you're talking about. So we have a simplification example. Here, our expression is simplified already. I cannot combine anything else. There's still absolutely subtraction going on, but none of these are like terms, so I can't combine anything. Thankfully, we have 2 other skills, or one skill with 2 sub-skills, to go ahead and manipulate this standard form. That is in factoring and then completing the square. So when I factor this, I use my box method, and that is going to give me x squared and negative 40. I need to figure out some combination that multiplies into 40 that adds up to be negative 6. And if you spend some time on this, you should be able to get negative 10 and 4. So this means negative 10x and 4x, giving me x and negative 10, x and 4. And this is going to factor into x plus 4, and then x minus 10. Okay, so this is going to be my new form. This is going to be equivalent form 1, and I just went from standard to factored form. I was able to factor this out. Now, that being said, I do have another avenue to go down, and that is in completing the square. So if you remember the skill from Unit 2, I once again mix my box, or rather than do my first and last term, I do my first term, x squared, and I split my x values. I split my x's so that both my sides are even. So that's going to be negative 3x and negative 3x. And this will give me a value of 9. Now I need a value of 9 in order to get there, or enable to use this. So that means I need to my 40, add 49, subtract 49, so that everything balances out. But this in turn will give me that 9 that I need. So this will give me x squared minus 6x plus 9 minus 49, giving me x, because this will turn to x minus 3, x minus 3. It'll give me x minus 3 squared plus 49. And this is my other factored form. I mean, it's factored, but the factoring method is called completing the square. But this is my second form, so I'm going to call this EF2. Now, how do I get that third form? Well, I can't really use my factored form, because if I multiply that out, that's just going back to standard. So in order to get my third form, I'm going to look at my completing the square values here. And what's going to happen is if I multiply these out, I'm going to get some new expression by multiplying out my x minus 3s. Oh, as a matter of fact, I missed a form. We could absolutely call this EF3. Because this is a different form than either my standard or my EF2. So yeah, I would absolutely count this. Now what you also could have done is from this point, written out x minus 3 times x minus 3 plus 49. I would have absolutely accepted that as a new form as well, so we'll call this EF4 even. But I just need 3 of them, guys. So if you could go through this process and just recognize all the different ways that you write this equation, I will absolutely take that. And finally, we have our expanding example. This mostly has to do with exponents. So this is an example of something to be given, and it's messy. So before even trying to find equivalent expressions, what I would recommend to you is to simplify each part as much as you can, and then try and go from there. What I mean by that is that I know that 6 divided by 2 is going to give me 3. I know that x squared divided by x to the 5th is going to give me x to the 3rd on the bottom. And I know that y to the 6th over y to the 4th is going to give me a y squared on top. All I did was simplify using my exponent rules in order to get my simplified version here. And already this is an equivalent form, so we'll call this EF1. And in order to rewrite this, I could expand out my parentheses. I could expand out my variables. This will be EF2 is just going to be me writing out my exponents. So that's going to be y times y and x times exponent x. This is my new form here. And in order to get my new equivalent form 3, I'm just going to play around with what I know about my exponent rules. So I'm also going to rewrite this as 3y, let's say to the 10th power, all over y to the 7th power, 8th power, let's do our math correctly, because I know that this y to the 10th divided by y to the 8th will give me y squared, which matches here. And if I look at my x's, I want x to the 3rd on the bottom, so I could say something like, hey, I want x to the 4th on top, meaning I would need x to the 7th on the bottom. You just need combinations that would get us 2 y's, y squared, or 3 x's, x to the 3rd, and you would be able to write this any number of ways. So with that being said, those are some examples of uh, using our expanding method to give equivalent forms. Expanding, you're going to want to use when you see something to a high power. You could begin expanding those out, writing them out as a series of multiplication rather than writing out the exponent. So that's the trick for expanding. May it serve you well. Okay, so if we're good with uh, writing equivalent expressions, then the only thing left to go over is our topic that we went over this last week, that being simplifying rational expressions. So there are 3 basic guidelines for doing this. First, you must factor as much as possible. Factoring includes using our area box method with our 4 boxes, or taking out what's in common, which we could also employ our box method, but it's just our smaller one, usually just with our 2 slots here, so that we could slide in our 2 binomials or our binomial values and figure out what I can take out and then what's left over on top. I will pull up the worksheet, so that is it for this particular review slide deck. But if you bring out your uh, simplifying rational expressions worksheet, I will be going over the examples shortly. Okay, so looking at our multiplying and dividing rational expressions worksheet, you're going to see problems that are going to look like this. Okay, so we have a multitude of examples, so we're not going to go over all of them together, but I will model just a few in order for you to get a sense of what to expect. So looking at number 1, this one is just multiplying straight across. So I'm going to rewrite this expression as x plus 4 times x plus 2 times x plus 2 all times x plus 5. Now, the reason I rewrite them together, but I don't multiply yet, is to give me an opportunity to cancel. And in order to cancel, I need something on the numerator to match something in the denominator. So since I have two groups that are matching, I can cross these out, making my final answer. This simplifies to x plus 4 all over x plus 5. And I'm done. That's all I'm looking for. So it can be fairly straightforward like this. It could be slightly more complicated when we divide, because the rules for dividing fractions, you must keep, change, flip. We went over this, so we're going to just edit, annotate our problem. So I'm going to change my division to multiplication. I'm going to flip my last fraction. So now it's going to be x plus 5 all over x plus 3. And I'm no longer looking at this second fraction as I rewrote it over here as the reciprocal. I kept the first fraction, changed the division sign to multiplication, and I flipped my fraction just so. And from there, once again, I looked if I could cancel anything. And I could cancel x plus 3 and x plus 3. So my final answer is going to be x plus 5 all over x plus 2. Okay? And once again, I am done. Sometimes this is a matter of going through the math and canceling anything. Where it gets slightly more complicated is if I do a problem like number 7. So number 7, I can't cancel anything as of right now. However, I know that by changing the form, I could potentially get parts that, or new groups that factor and cancel with what's remaining. So whenever you're given a quadratic like this, I need to factor. So in this case, that factoring is going to look like x squared and 6. And in order to get 5, that's going to be 2x and 3x, giving me x and 3, x and 2. So I'm going to rewrite this as x plus 3 and x plus 2. Similarly, for my bottom quadratic, that's going to be x squared, and that's going to be 10. And if I'm aiming for 7, that's going to be 2x and 5x, giving me x, 5, and 2, meaning I could rewrite this as x plus 2 times x plus 5. From here, I can start canceling. Remember, I can only cancel top to bottom. I can't cancel this 2x with this 2x because they're both in denominators. But I can cancel this 2x with this 2x. I think I kept saying 2x, x plus 2. I can cancel this x plus 2 with this x plus 2 because one is the numerator, one is the denominator, so I'm dividing by them. When I'm dividing by anything by itself, it cancels. Looking again, I have x plus 5 in the denominator, x plus 5 in the numerator, and they cancel, meaning I'm left with my answer, which is x plus 3 all over x plus 2. And that's really what we're looking for. Now, these questions get harder as you go along. One thing I want to highlight is something like number 6. Here we don't have any multiplication or division sign in our answer or in our expression. So sometimes you'll just be given one fraction that you need to do the same thing, factor and cancel, deal with whatever you can. In this case, you'll notice that I have an x minus 4 and x minus 4 here. But this time, these are parentheses taken to a power. So knowing what I know about exponents, I realize that I have 3 x minus 4s up here, and I have 2 x minus 4s down here, which means I could cancel 2 of them. So I'm going to cancel out 2. And rather than cross out my whole x minus 4, I'm just going to cross out my exponent. I cancel 2 of them, one's left over. That's going to be x minus 4, so the first power. And then 2x minus 1 and 2x minus 1 both have 1 power, so those cancel. And this is just going to be equal to x minus 4. So it's not always about factoring. It's not always going to have multiplication or division between fractions. Sometimes it's a matter of cutting, simplifying, and getting what your final answer is. So I will leave you guys to try the rest of this worksheet on your own, except... Let me go over number 10, and I'll zoom in just so I have more room to actually write. I'll go over number 10 just because this is the hardest question on the worksheet. So this is very similar to what we did in class, where each part is kind of a question unto itself. So let's go ahead and systematically try and break this down. I'm going to zoom in because I need as much room as I can to go and write down my answer. So 4x minus 12, I'm going to look at my numerator first. This is going to be, this numerator has the 4 in common, so I'm going to factor out a 4. So I'm left with x minus 12. X minus 3, because I took out a 4. 12 divided by 4 is 3. And I completely factored my numerator here. I saw what was in common, and I was able to take that out. Looking at my denominator here, this one, I factored like normal, so that's going to be x squared, then negative 10. In order to get my positive 3, I'm going to break this into 5x and negative 2x, giving me x and 5, x and negative 2. And I actually want to do this in a different color. So let me do all this in red just so I could keep everything color coded. That's going to be x squared, 10, negative 2x, 5x, x and negative 2, x and 5. This is going to give me x minus 2 times x plus 5. And now I've fully factored my first numerator, or excuse me, my first denominator. Now, you'll notice that we are dividing. So before I move on to my next fraction, I'm going to employ my keep, change, flip. I keep my first fraction, which is why I could work on it before without needing to do this yet. I multiply this. I'm going to cross this out and rewrite it as 2x squared plus 3x minus 35 and 2x squared minus 13x plus 21. Okay? From there, I'm going to go ahead and factor these. Now, both of these have an a in front. Let's use another color for this one. Let's go with orange. So you'll notice that I have a value in front of my x squared, which is going to change my factoring slightly. Let's make my box here. That's going to give me 2x squared and negative 35. Now, because I have a value a in front of my x squared, what I need to do is I need to make my generic diamond. And what I need to put on top is my AC value. What I need to put on bottom is B. My AC is my first term and my last term, and multiply them together. That's going to give me 35 times 2, which will give me 70 x squared, and it goes for doing negative and positive, plus me negative 70. And my middle term is going to be my b value here. That's going to be 3x. From there, I need to figure out what on earth multiplies into 70 that will also add up to be 3. And through some clever workings, we could realize that, hey, 10 and negative 7 work out. 10 times negative 7 gives me negative 70. 10 minus 7 gives me positive 3. So I found the combination that works, 10x, negative 7x. And I throw that into my box. And I factor out my first box, this being x and 2x. I put the 2 up here specifically so that it aligns with my 10 and it doesn't align with my 7. 2 shares the multiplication factor with 10 and not with 7, so putting the 2 here makes it easier to work with. 2x times 5 give me 10x. If I had it applied with the 7, it gets some fraction. And here, this just becomes negative 7, because x times negative 7 will give me negative 7x. Meaning I could rewrite this as 2x minus 7, x plus 5. Okay, and finally for our third color, let's go ahead. We always use red, pink, can't use white. Hopefully green is not too hard to see, but we're now going to factor our final part, our final denominator. That's going to be 2x squared. And that's going to be, oh, that's supposed to be 21. Couldn't understand my own writing for a second. That's going to be 21. And once again, I have to make my cross, my diamond. And this time it's going to be 42. 42. And I want it to equal to negative 13. X, of course. This should have an x squared. And if I remember multiplication facts, I know that 42 can be made by multiplying 6 and 7. That will add to be 13, but I need a negative 13. So if I make both of them negative, that still works. Negative 6 times negative 7 gives me positive 42, and negative 6 plus negative 7 gives me negative 13. Throw an x on both of them, and I found my combination that works. So let's call that negative 7x, negative 6x, and we'll take out my 2x here, x here, give me negative 3 here, negative 7 here. This will give me x minus 3, 2x minus 7. And quite a few things can cancel now. So let's look back. I have an x minus 3 here. I have an x minus 3 here. I have a 2x minus 7 here, 2x minus 7 here. I have an x plus 5 and x plus 5. And I've canceled almost everything, but my final answer is going to be, it's right here in the corner. This whole thing is going to just be equal to 4 over x minus 2. That's all that's left over. So after all my canceling, that's what my answer is, 4 over x minus 2. So, can that get very involved? Yes. But if you just look at each part, you could count this as 4 questions in one even, and just bring all the answers together to cancel at the end. Please just keep your work organized, and I promise you'll have an easier time of it than it initially seems. So, I was able to model quite a few problems for us. Hopefully this helps. I wish everyone luck studying over the weekend. If you have questions, please email me, or else we can go over any questions before we start the test on Tuesday, Wednesday for us. All right. Happy studying. Have a good one.